Hello, my name is Shelly Ransom. I'm here to share my work completed thus far for my summer undergraduate research. Here's everything we have on the agenda for my presentation. I will start with talking a bit about myself and the research project, describe my initial goals and tasks, dive deeper into the work I have done, and end with a discussion on my next step. I am from Clayton, North Carolina, and I'm a current undergraduate student here at North Carolina State University. I'm currently pursuing a bachelor's in mathematics and will graduate in the fall. I have also recently finished my first degree in biological engineering with a concentration in agriculture. I started out solely as an engineering major, but I always dreamed of adding a second degree in mathematics, which I did, and now I'm going to end up with 2 bachelor's degrees. I love the field of agriculture. I'm a member in a professional agricultural organization, which allows me to network and meet individuals in the field. And I also have previous internship experience in agriculture, which exposed me to growers all across the state of North Carolina. This research experience was a great fit for me as it combines areas from all of my interests: agriculture, math, statistics, and data analytics. It's exactly what I want to do. I joined the research project in May of this year. The project is a game-changing research incentive program for the Plant Science Initiative 2020 grant winner, entitled Improving Crop Productivity and Value Through Heterogeneous Data Integration, Analytics, and Decision Support Platforms. It is a huge interdisciplinary team with individuals from electrical and computer engineering, biological and agricultural engineering, computer science, plant and microbial biology, horticultural science, and entomology and plant pathology at NC State. Some industry partners include Exeter Engineering, Scott Farms, Intero Life Sciences, and SAS. The project consists of 4 comprehensive strategic goals. Strategic Goal 1 deals with stakeholder interaction. 2 encompasses the development of a custom imaging and sensing platform. 3 deals with data analysis and the creation of a database. And Strategic Goal 4 is focused on training, outreach, and further engagement with those in the industry. This research is important because it addresses something all of us should care about: food waste. Sweet potatoes are valued based on their looks, and deformed ones are often left out in the field and not even harvested. It is important to identify what factors, apart from genetics, potentially shape sweet potatoes. Now, I could spend a great deal of time talking more about the entire project, but now it is time to elaborate more on my undergraduate research experience and where my work fits into this big picture. My efforts were focused specifically in Strategic Goal 3. I was tasked with the collection and curation of weather data, soil data, and cultural practices such as irrigation and pesticide application, and to determine possible relationships between these variables and sweet potato shape. I utilized R, the statistical programming language, to tidy my data, perform statistical analysis, and start the creation of a web app for soil and weather data creation and interpretation. At the start of the summer, I was tasked with completing 3 milestones: identification of data sources, creating summary statistics, and performing statistical inference to identify significant variables that may affect sweet potato shape. Now I'm going to dive in a little deeper into my work towards milestone 1, the identification of data sources. Before I joined the project, efforts were already made to develop a computer vision algorithm to extract sweet potato shape features from images captured by an Exeter automatic sorter, pictured here on the left. The resulting shapefile includes a multitude of measured and calculated characteristics of the sweet potatoes, such as axial length and max diameter. These tables for 2018 and 2019 sweet potato trials, grown and scanned at the horticultural research stations in Clinton and Princeton, North Carolina, have thousands upon thousands of entries. So we already have the sweet potato shape data. It was my job to help collect and tidy the data from other sources. There are weather stations scattered all across the state, maintained by the North Carolina Climate Office. These stations collect tons of measurements such as precipitation, soil moisture, and dry bulb temperature. On the North Carolina Climate Office's website, I downloaded weather data from the Clinton and Princeton weather stations for dates during the 2018 and 2019 growing period. Real-life data is often messy data. There's a saying that a majority of data analysis is just cleaning up the data into a format you can work with. Thus, my next step was creating a script in R to tidy the weather data and aggregate the hourly observations into weekly ones. On top of this, I also wrote a detailed procedures document with pictures outlining steps for retrieving the data in order to ensure my work can be reproduced. And throughout the entire summer, I was mindful of doing work, especially while writing my scripts, that can be used for the 2020 trials and beyond. For this reason, I began creating a web app using R that would allow users to upload a CSV file and utilize my script to tidy and provide some preliminary visualizations. In addition to weather data, I also identified a source for soil data. The North Carolina Department of Agriculture and Consumer Services have a lab that offers soil sample analysis to landowners and producers that tells them levels of important macronutrients and micronutrients in their soils, and also provides recommendation for fertilization or other treatments. Initially, we had this data from the horticultural research stations as PDF files, but I was able to do some digging and find the same reports publicly available with the option to export as CSV files. I was then able to load the files into R to tidy them as well. Just like the weather data, I also started working on a web app that would allow the user to upload one of these exported CSV files and tidy or provide some visualization. Next, I gathered cultural practices data. This includes irrigation times and amounts, fertilization application amounts, and pesticide application amounts. This information was provided as PDF files. Since there are so few sweet potato trials in 2018 due to hurricanes, I was easily able to manually enter this data into an Excel sheet. However, this is not an ideal situation moving forward. Across the various horticultural crops research stations, there's no standard way of documenting and recording this data. I am working with individuals at the stations to try and create one standard spreadsheet template to make all of our lives easier. I will spend some time talking about the summary statistics I've made for the weather, soil, and shape files for the 2018 data. Here is an example of a neat table that gives summary statistics for 2018 weather data in Clinton and Kinston. It details the number of missing values, if any, the mean, standard deviation, and a few percentiles, including 0, which is the minimum, 50, which is the median, and 100, which is the maximum. You can also see a tiny little histogram plotted for each variable. I want to dive a little further deeper and illustrate the results for average dry bulb air temperature and average soil moisture. Here we see summary statistics for the mean temperature at each site. For a reminder, there are the minimum, medium, and maximum values for each listed right there. The two histograms shown on the top are identical. There is the same distribution of mean weekly temperatures, but no, the mean temperatures themselves were not equivalent for both sites. And below you can see box plots which showcase the first and third quartiles as well as the average temperatures week by week. Both locations are extremely similar, which kind of makes sense since they're both in eastern North Carolina and are only about 50 miles apart. Week 0 is the week of planting, which is the week of June 24th, 2018. You can see as the weeks pass and we enter into fall, average temperatures start to drop off significantly. This is as expected. Here we see summaries of soil moisture in 2018 at both sites. The volumetric water content of the soil was measured, so the units here are cubic meters of water per cubic meters of soil. Overall, we see soil moisture varies more between the sites than the temperature did, most likely from differences in precipitation. I'm going to have to keep these variations in mind as I move forward with my research and also take a note of where these soil moisture sensors were placed to determine if irrigation also played a role in this variation. Here's a table of summary statistics for sweet potato shape features, which are of big interest to me. There are many, many more variables here that have just been cut off from this image, but it is just to give you an idea of what this data looks like. Again, I will dive deeper into two variables, length to width ratio and curvature. The length to width ratio is just what it sounds like, the length of the potato divided by the width of the potato. It is one of the important physical characteristics that come into play when potatoes are graded or sorted and valued based on size and shape. The histogram shown here displays average length to width ratio, which is about 2, as the vertical blue line. We can see a very nice kind of narrow distribution of potatoes centered around the mean here. And when you go to compare potatoes from the two sites in the box plot, you see their averages are extremely similar. Moving on to curvature, yet another important physical characteristics of sweet potatoes, we see our distribution here on the histogram with the mean shown as the blue line once again. Similarly to length-width ratio, the mean curvature at both locations is nearly identical. At this point, I've gathered most of my data, done a lot of tidying, and inspected my data. I'm still finishing up gathering up some cultural practices data and tidying 2019 weather tables, but I'm overall very pleased with how far I've come so far. Milestone 3 is where I still have work left to go, but I have dipped my toe in the pool of statistical analysis on some of my data. Some of the potatoes from the 2018 trial were labeled based on their shape, such as good, bad, or tailored. Out of the tens of thousands of sweet potatoes scanned in 2018, only about 1,300 were labeled. Of those thousands were from Clinton and the rest were from Kinston. Since there is only one trial from each location, there is only one soil sample result from each location. That's not exactly setting myself up for the best model, as we can see here in the scatter plot matrix. There's basically only two measurements for each of the soil components for each potato, either results from the single field in Clinton or the one in Kinston. In the 2019 trials, this will be a very different story. There are about 20 trials in different fields with unique soil properties. Nevertheless, I carried out a simple binary multiple logistic regression on this data just to start somewhere. Here are the results of the multiple logistic regression of the soil sample properties against a binary classifying for the labeled potatoes, either good or bad in terms of shape. This is telling me here that only humic matter, or the portion of organic matter in the soil which is decomposed into humic acid, is statistically significant, which means it might factor into shape determination of sweet potatoes. The coefficient is positive and in this case quite large, which tells us that for each unit increase in humic matter, the probability of a sweet potato being labeled as good increases. Again, for the reasons I stated before, I'm wary of this model, but it did just provide a step one. Next, I want to fit a linear regression model which accounts for soil, weather, and cultural practices data against continuous shape factors, not just the labeled or classified data. I'm interested in looking at the length-width ratio and the curvature in particular. I'm dealing with a lot of variables, so it'll be important for me to eliminate some of them. I want to conduct coefficient shrinkage for variable selection, so my next model will likely be a lasso regression. I also need to finish my weather and soil data applications that I mentioned earlier. And then another task I need to complete is the digitalization of hand-drawn field maps for the horticultural crops research stations, using ArcGIS Pro to utilize yet another potential data source, land surveys, which will data on some water properties and other soil features of interest. And then that way we'll be able to connect it back to the specific plots in the field and assign that data to a particular potato. Thank you so much for spending the last few minutes with me. I've thoroughly enjoyed sharing the work I've completed so far, and I'm excited to see where my work leads me next. If you have any questions, words of encouragement, advice, you can leave them in the text box in the virtual Symposium interface, or you can reach out to me at my email address shown right here. I'd like to end my presentation with a fun sweet potato fact. Most people interchange the terms yam and sweet potato, but they're not the same thing. Yams are not grown in North America, and it's mostly just sweet potatoes sold here. I know sometimes you'll go into the grocery store and you might see a box labeled yams, but they're not yams. They're sweet potatoes. Thank you.